Watch, pause, write, watch, pause, and write. What does WP, WWP, 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 WWP mean? Watch means you watch these videos, then you pause the video, write down the question and do it, then watch it again, pause, write it down. That's how it works, WP, WWP, W. And if you can say that really fast, congratulations, you'll win the prize. Let's go to the board. Today what we're going to do is Unit 2 Geometry. This is an Apex program, and what Unit 2 Geometry really has to do with essentially is triangles and the qualities of triangles. Congruence, similarity, there's theorems, there's various things that we're going to learn about that by doing some questions. So let's go to the board. All right, so we're looking to find the missing angle in a triangle, and the main thing we use for this is knowing that all of these angles add up to be 180 degrees. Algebraically, that says 42 plus 87 plus x is equal to 180. So we're really just solving an algebraic problem. 42 and 87 is 129. We have plus x equals 180. We're subtracting 129 on both sides, and we end up with x equaling 51 degrees. We go back and check it. Is 51 making sense? If we add 51 and 42, we get 93. Add the 3 to the 7, and we get 180. We indeed do. Don't forget to make your check and box your answers. I think any of these problems we do are going to be like that. Just bear in mind here that this is an acute triangle. You need to know all of your definitions. An acute triangle means that it looks really cute because all these angles are less than 90 degrees. So it's called an acute triangle. This one over here is an obtuse triangle. Let's put our attention on that because the angle here is bigger than 90 degrees. So obtuse triangles have angles that are bigger than 90. Acute angles have angles that are less than. These ones are also smaller than 90, but at least it has one angle that is bigger than 90 degrees. So same idea here. We got 30 plus 110 plus x, and it equals 180. So we're going to subtract. I'm going to add it's 140 plus x equals 180. I really don't mind taking my time here, you notice, and I'm going to do all the steps. We got x equal to 40 degrees. Go back and check it. Don't forget to box it. 40 plus 90, or sorry, 40 plus 30 is 70 plus 110 is 180. We're good. That's an obtuse triangle. I didn't do a right triangle, but I think you get the idea. A right triangle always has a perpendicular, a symbol for that right there. That would be 90 degrees, so that's called a right triangle, and those are the basis of our three cases here. Thanks very much. We'll go to the next problem. All right, so this problem, be careful. This symbol here means similar, so it doesn't mean congruent. A congruent symbol is like this. This is congruent. It's a squiggly with an equal sign, and a similarity means just a squiggly. So this right here is similar. Make sure you're aware of the difference. All right, so triangle ABC is similar to DEF. What is the length of EF? That would be this segment here. What we do know from similar triangles is that they are in proportion. The sides are in proportion. So we put DF right here, this lower part of the triangle, the base, over AC. We know that's a proportion. And we're going to get 10 over 15 as a fraction, right? And then over here, similarly, ED over AB. ED is 4, and we're going to write equals because these are proportionate ratios. ED over AB, which is 6, and now we're going to get to the thing we don't know, which is here, which is EF, which is like the far or the longest side, EF over 12, but we can figure this out by taking these ratios. So we'll take something like this, we'll solve this for x, we'll go 4 over 6 equals x over 12, and then we cross multiply, we get 6x equals 48, right? Because we're cross multiplying there. We divide by 6, and we get x equals 6 times 8, which is 48, and that's our answer. Let's go back and double check. Does it make sense? Of course it does. It makes total sense, right? It makes sense in the proportions of this. 6 times 2 is 12. 12, 15, 4 times 2 is 8. We look at that, we make sense of it, and we get an answer. So this is called scale factor. The scale factor here, okay, because the if we're looking at this as the original triangle and this is the new triangle, then it means that this one's getting smaller. So if they don't tell you that, you can't necessarily know which one's getting bigger or which one's getting smaller. But if this is the original, okay, then it means this is new. Then the scale factor would be 4 over 6, or if you reduce it, it's going to be 2 over 3. That means that any side here is going to be 2/3 as big as that. And you multiply 6 times 2/3, you're going to get the answer, which is 4. And if you take any side, 15 times 2/3 is going to be 10, etc., etc. And this is 10 is 2/3 as big as that. So this is an example of scale factor, similarity in triangles, proportionate ratios, and everything is related to that. Let's go to another question. This kind of triangle problem has an extended line in the base, and then you're asked questions about not only this angle here, but this angle out here. So we're trying to actually find this here. It says the angle on DAB. So this is actually what we're headed towards. But we do need to know that, we need to use the information that triangles, the angles in triangles add up to 180 degrees. And that's what we've got here. Algebraically, x plus 33 plus 85 is 180. And now we just solve for x. We've done this before at the beginning of the video. So these two add up to 118, and then we subtract that on both sides, and we get, over here, we get x is 62. Now that we know that, we can use that information and figure out that this whole thing, this entire thing, okay, these two angles right there are equal to 180. So we write x plus y equals 180. We get 62, we know is x, plus y equals 180. Subtract 62 on both sides. Y is equal to 118. Now, you notice that, you go, hold on a second, that was 118. Is there some similarity going? Well, yeah, there is actually. This is 118. These added together, these two together, are exactly equal to that there. That's another thing that you'll notice as a theorem. But this is a different way of figuring that out. If you knew that, you could actually just go right ahead and tell us what the measure of that was, just without any of this, doing any of this. But I wanted to show you the full version of that and also allow you to realize that that is a theorem, that the opposite angles here are equal to this angle here, the exterior angle of a triangle. Okay, thanks. Let's move on. So this problem, not too much different than the other one, but notice the exterior angle is out here now. So, but we still use the same facts. You're looking for the measure of angle ACB. That would be ACB. By the way, that's how you write angles. You start with one point there. You get the angle itself as the second one, and then B over here. So we're going to call that y. We've got this unknown called x, and we're going to start with this. We know that x plus 70 is equal to 180. That's a straight line, so we know that. X plus 70 equals 180. To subtract by 70 on both sides, it means x equals 110. By the way, 70 plus x these are also linear pairs. 110 and 70 are equal to 180. So we use this now because x plus y plus 20 equals 180, because the angles of a triangle are equal to 180. So now we're going to put in 110 for x. We still don't know what y is. Plus 20 equals 180. We do the algebra, and y equals 50. We go back and make sure it makes sense. If this is 110, that's 20, that means that's 130 and 50. It all makes sense. Also, does it make sense? Does this, right now, if we look at this, is it going, if this is 20, this is 110, and this is 50, are these two angles, the other thing we want to check, are these two angles equal to 70? Well, if that's 50, which it is, if this is 50, which it is, that 50 and 70 are going to equal to that exterior angle. So that's a theorem, that's something you need to know as well. But for now, you also need to know how to work it out. That means you got to figure out this linear pair is equal to 180, work that out, and then use that in your triangle sum theorem to get your 50 degrees. Okay, hope it makes sense. All right, well, we have reached the end of the video. I wanted to show you one last thing, however. The congruence triangles. There's congruence triangle theorems, and they are put in a way that works like this. SSS, SAS, and ASA. Those are also things you need to use in order to solve problems that involve congruence. So when two triangles are congruent, they may follow one of these patterns. One way to remember this is Sa-sa-sa. Let's say it together. Ready? Sa-sa-sa. That's right. It's like a snake. Sassy, like a 4-year-old. And asa. Sa-sa-sa. There you go. Hope it works. Have a great week. Let me know if you have any problems. And see you on the other side. Hi, who do we have here today? Who's rolled in?
My name is Libby.
And I'm Vivian.
Where are you guys from?
We're from Sydney, Australia.
Wow, down under. That's amazing.
Yes.
Hey, how are you so successful at math, Libby?
I'm so successful in math because I watch Mr. Day's videos.
Oh, really? And is it like TV to put your feet up and watch it, or you do something different?
No, it's actually really helpful if you're struggling with math work because Mr. Day follows a formula. It's watch, pause, write. Watch, pause, write.
Watch, pause, right. Do you mind saying that for us, too?
Watch, pause, write. Watch, pause, write.
All right, out there, so everybody get it right. So, she'll be right?
She'll be right. Good luck, guys. Bye.
See ya.